In this video, you will see the practical implementation of artificial neural network. And for this video, we are trying to solve a regression problem by practically implementing ANN in TensorFlow. So the problem that we are trying to solve is we want to predict the price of gold based on other features like the price of silver, S&P 500, that is the US stock market index. Then we have a Euro USD pair and the price of oil. So these are some features that we are going to use to train the neural network, and it will predict the price of gold. So let us start. First of all, I'll import the required libraries, that is import pandas as pd, import numpy as np, and from sklearn dot model underscore selection I need to import train test split. From sklearn dot pre processing I need to import standard scaler, and from sklearn dot pre-processing I have to import min max scaler. So these are some libraries that we want, and now I'll import some libraries from TensorFlow and Keras to implement our neural network. So import TensorFlow STF. From TensorFlow I need to import Keras. From TensorFlow dot Keras I'll import the sequential model, so sequential, and from TensorFlow dot Keras dot layers I'll import the dense layer. So these are some libraries that we need to implement in neural network. Now let me show you the data and explain the problem that we are working on. So I'll create a pandas data frame. df will be equal to pd dot read underscore csv, and the data we have is gold price underscore data in csv format. So first the cell will run. It will take some time to import the libraries. Then once the cell is successfully executed, the cell will execute, and let me write df.head, and we'll wait for these to get executed. Yeah, so this is the data set. As of now, ignore the date column, we won't be working with that. This is the SPX S&P 500. This is the price of gold, our target variable. The US oil, SLV, silver, Euro USD pair. So SPX, USO, SLV and Euro USD will be our independent features, and based on that we'll try to predict the target, that is gold. So let us start with the problem. Now I'll separate my x and y dependent and independent features. So for x I have df of the first thing that I need is SPX, then I have USO, and I have SLV, and finally the fourth feature I have is EUR slash USD, and y will be equal to df of the target, that is gold. So I have my x and y separated. Now let's split the data into training and testing part. So I'll have to create x train, x test, y train and y test. So for that I can do x train comma x test comma y train comma y test. This will be equal to train test split. Over here I have to give x comma y comma the test size that I want to use, that is equal to 0.2. So I want to use 20% data for testing part and 80% for training part. Now let's scale the data so that we get better results after implementing the neural network. So I'll create the scalar object, and for min max scalar, the scalar object is created, and we'll create x train scaled and x test scaled. So I can write x train scaled, this will be equal to scalar dot fit underscore transform, and I will pass xtrain over here, and I want to create xjust scaled. This will be equal to scalar dot transform, and I'll give xjust over here. So now I have created my xtrain scaled and xtest scaled. I'll create my neural network, the model, sequential model. So I'll write model that is equal to sequential, and then this will create my sequential model, and I'll add different layers. So firstly I'll write model dot add function, and I want to add this dense layer with 10 neurons, and the activation function for this layer that I want to use is ReLU. And finally the input dimensions, the number of input features that we're using, that is SPX, USO, SLV and Euro USD. So this input underscore dimensions, that will be equal to 4. And finally let me add this another layer, model dot add one hidden layer. So again a dense layer over 10 here, and this time again the activation function will use this ReLU. And finally we have our output layer, so model dot add, and this is a dense layer with, since this is a regression problem that we are solving, so we'll have just one single number in the output, so I have just one neuron. And again this is a regression function, regression problem, so the activation we'll use in the output layer will be linear. So this is the model that we have implemented. Now let's compile this model. So I'll write model dot compile, and over here my loss is equal to mean squared error. So this is the loss function that I have. We'll calculate the mean squared error, and we are going to use optimizer. This will be equal to add. So here this is the model compilation. Now let's train the model. So I'll create this history, and this will be equal to model dot fit method, and here I'll pass my xtrain scaled and ytrain. So I give xtrain underscore scaled, this is scaled, and then I want to train it with ytrain, and I'll train them for, let's say, 50 epochs, and I'll create a validation split of 10%. So validation split will be equal to 0.1. So this will train the model for 50 epochs. As you can see, it is showing this is the first epoch, and it will go until it iterates over 50 times. So we are training the model for 50 epochs. Now once the model is trained, I'll store the predictions made by the model on xtest. So I'll create this ypred, and this will store the predictions. So model dot predict, and I want to make predictions on x test scaled. So this ypred has now stored all the predictions that the model has made on x test scaled. And let me import, since we are solving a regression problem, so I'll use the metric called R2 score to evaluate the performance of our model. So first from sk learn dot metrics, I have to import R2 underscore score, and then I'll calculate R2 underscore score over here. Firstly, I have my y test where the original or the actual data lies, and here I have my ypred. So the R2 score that we're getting is around 73%, which is actually a very decent R2 score. We haven't run the model or trained it for multiple epochs, but still only for 50 epochs we are getting a decent R2 score of 73%. So this is the complete implementation of a regression problem using artificial neural network in TensorFlow. I hope you're clear with all the concepts that are discussed in the video. Thank you for watching. Now let's move to the next one.